Okay, what do we mean by this? Bi here means two. Like bicycle, bisexual, bi whatever means two. This means we're only going to take the compounds that have two different kinds of elements in them. And we're taking it step by step. Now in real life, it's all going to be thrown at you at one time. But as we learn it, we're going to take little bits and pieces. It's like if you were learning a foreign language. You start first, you talk about the present tense. And then when you get more advanced, you add on the past tense or the future tense. But they don't throw all that stuff at you at one time. Your brain couldn't cope with it. So we're going to talk first about binaries. And the first type of binary, this is going to be part A. We are going to use a non-variable metal plus a non-metal. Many compounds come together. You have a metal and you have a non-metal. Because what was our definition? Metals are those things that tend to lose electrons and become cations, and non-metals tend to gain electrons and become what? Anions. Okay, non-variable. What does this mean? It means the metals, we are sure what their charge is. For instance, a 1A metal, if it takes on a charge, what charge does it take on? Always, Hina? Plus 1. It's non-variable. If we have a metal from the 2A family, Meredith, it always takes on what charge? Plus 2. If you have 3A, especially aluminum, the charge, Emily? Plus 3. Good. Now, to add to your burden, we generally do not include B families, the transitions, because they're they're variable. There's 2 of them I want you to include. If you have zinc, it is non-variable. It is going to be plus 2. And if you have silver, it is going to be plus 1. And let me tell you a couple of ways to help you remember that. Look at the positions here. Zinc. Okay, if I were doing an electron configuration of zinc, I'm back in chapter 4, whose core would I use? Zinc. If I'm doing electron configuration, whose core?
Argon.
Argon. So I would say argon core, 4s2, and then 3d, how many? 10. Okay, zinc would become plus 2, and only plus 2, because it's going to unload those 2 4s electrons. It still has the fantastic stability of having a full D. Remember how we talked about full Ds or half full Ds are fantastic in stability? So zinc becomes plus 2. It's kind of odd. This is for you heavy-duty thinkers. That the filling order, we say argon core, and then we say 4s2, and then 3d10. The 4s's go in first, and then the 3ds, but the first in are the first out. So we lose those s's first. So zinc becomes plus 2. Now, silver. Remember how I said your responsible copper is an exception? Because if we could transfer 1 electron, and we talked about copper as ending up 4s1, 3d10, and then I ask you other exceptions. Well, silver would be another exception. So silver becomes plus 1 because silver would end up, let's see, krypton core, 5s1, 4d10. And so it trashes that 4s. So that's one way, if you're academic, that's the way to think of where that came from. But a trick. You know aluminum, right? Charge on aluminum is always what? Plus 3. Okay, nice diagonal. Plus 3, plus 2, plus 1. You know aluminum, work your way down. Aluminum, 3, 2, 1. Okay, those are the ones you need to know. Now, as we play this game, we're going to do it 2 ways. We play the game twice, and Al does a really good job practicing with this. I give you a formula, you give me the name. Or, worse, harder, I give you the name, and you go back and give me the formula. Okay, and here are the rules. Let's say I have that. It falls under that category because my metal is non-variable and iodine is a non-metal. Okay, here's the rules. The positive part you just say as is. No special ending, you just say potassium. And it's not an unambiguous, or pardon me, no, it's not ambiguous at all because we know potassium is always +1. Then, here's the new part. If it is a binary compound, your ending is "ide," I-D-E. So we're going to say iodide. You drop the original ending iodine, I-N-E, ide. When you hear it spoken, that's your clue. It's binary and there's nothing hidden there. It only has potassium and iodine, potassium iodide. And I believe that's what they've been selling when people were afraid of the radiation out on the West Coast. They were selling potassium iodine tablets so the iodine would get to your thyroid and you wouldn't be picking up radioactive iodine and block out your thyroid gland. Not a good plan without a doctor's supervision, because if you get in too much potassium, you can die. Because it can upset your heart the beat. You'll have a irregular. There was a marathoner a few years ago, young guy, was taking potassium supplements. No, this is for you, because I think you told me you were taking some potassium. This marathoner was taking potassium. He was just, freelancing, not under a doctor's supervision. He finished the marathon and dropped dead just a few feet past the finish line. And when they did the autopsy, it wasn't the, running the marathon. It was, he had an unbalance in his electrolytes. He had way, way, way too much potassium. And so you don't want to be freelancing and taking that on your own because you're afraid the radiation from Japan is going to blow in. Okay, so naming, to get back to naming. Ide. Okay, let's do one more this way. I have. See, I give you the correct formula, and then you're going to name it, and you just read it left to right. This falls in this category because that is non-variable. And so we would say, Nina?
Magnesium chloride.
Perfect. Magnesium chloride. Okay. Now, it's harder if I do it this way. Calcium oxide. I know it's binary because we got the ide. That means there's only calcium and oxygen. What we have to do is say, okay, I got some calcium, I've got some oxygen. The calcium right here, Nikki, what's the charge on the calcium?
+2.
What's the charge on an oxygen?
Or -2.
-2. What's the formula?
So CaO.
Just
CaO.
Just CaO. Okay, so be able to play the game both ways. Now, life is going to get a little harder. We're going to take variable metals with nonmetals. And most of your transition elements are variable. I am picking a select 5 of them. Need to know. Flashcards, whatever it takes. Iron can exist as +2, or iron can exist as +3, depending upon experimental conditions. Copper can be 1, copper can be 2. Depends on experimental conditions. Mercury can be 1, mercury can be 2. And then tin can be 2. And unusual reasonable, but not impossible. Tin can be 4. Lead could be 2. Lead could be 4. You just have to know what exists. And you can't tell really well by electron configuration as we could for the others. Names. There's a nice, easy way to name them, and there's a hard way to name them. And we're going to get comfortable with both. We're going to use the newer way, and here's the newer way. You just say the word in English. You put Roman numerals directly behind it. That's the easy way. And so forth. Now, the other way is to use the Latin. And this is harder, but until all the old chemists die off, it's still going to stick around. So this can be iron 2. You go to the Latin. The correct ending here is us, O-U-S. For this one, it's ick. Now, what do these endings mean? Us simply means it's the lower charge. You have to know what exists, and we'd say, oh, for iron we've memorized it's +2 or +3. The lower is 2, therefore it's ferrous. The higher is 3, therefore it's ferric. Let me do one more. I know it's 11:20. This would be cuprous. Notice now, this is what is a hard one, because in English we spell copper with an O and 2 P's. The Latin spells it with a U and 1 P. +1 is the lower that exists, so it's cuprous. Take a wild guess. What is this one? Cupric. Okay, they do not use the Latin here. I'm just going to say this, but by next Thursday, look all this over and we're going to pick up here. Mercurus, mercuric. Stannus, stannic. Plumbus, plumbic. Okay, lower and higher. Notice one thing, super important. The ending us does not mean 2. The ending us means it's the lower of the 2 that exists. So in this case, the us is with a 2. Here the us is with a 1. So remember, lower and higher. It's kind of like senior and junior, or junior and senior in a family. And
Will this go in test?
of course,
Well,
part
I
of
wasn't
chapter
sure,
6.
or I wasn't sure if it was this test or.
No, it's this one.
Okay.
We'll have the leftovers of chapter 3, all of 4 we covered, all of 5 we covered, and all of 6 we covered together. If I skipped a section, then you're not responsible for that. But this naming, yeah. So get a head start on naming. I'd say put aside 10, 15 minutes every day. Get yourself some flashcards. Hit it.